It's a continuous function. G is a continuous function. At 2, G has an output of 5. This is a piecewise of G prime from -3 to 7. So this is a graph of the derivative of G. Find the x-coordinate for all points of inflection and justify your answer. So if I want points of inflections, well, what you have to realize is if I want points of inflections, I want to find when G double prime x equals what? 0 or does not exist, and changes positive to negative or negative to positive. That's what I'm looking for. And that will help with justifying. I'm looking for those particular pieces. Now next, if this is G prime, how do you get G double prime? Well, aren't they the slopes? So what I do is I look at this graph and I find that when does G double prime x equals 0 or does not exist at x equals -1, 1, and 4. Those are your places where it does not exist. Basically, they're all does not exist here. There's no equals 0. So those are your possibilities. Now, out of these, which of these we're looking for here? We need this stipulation. Which ones have a change, either positive to negative or negative to positive? So when you look at this, the only ones possible would be x equals 1 and 4 are your answers for P of I, points of inflections. These are your points of inflections. The reason is G prime x, the second derivative of G prime x changes signs. The second derivative of G, basically the slope of G prime changes at these 2 points. The slope of this graph changes at these 2 points. This one does not work because it does not change. Now, the next one. If we're doing B, find the absolute max of G. Now, to find absolute max, you need to first find the relative maxes and the endpoints. So to find relative maxes are when G of x equals 0. So where does G of x equal 0? Well, if we look at this problem, where does, G prime x equal 0? It is at x equals -1, 2, and 6. Those are your 3 places where it equals 0. Next, I want to then look at this graph, and you also need it. The second stipulation doesn't have to change. Don't you also need, for it to be a relative max, don't you also need that this double prime is what? The second derivative is positive or negative? For it to be a max, doesn't it have to be sad? So it has to be less than 0. So would the second derivative of this be less than 0? Basically, does this change from positive to negative? This is negative to positive, negative. I'm stupid. Ignore these marks. Does this one change for a maximum? Went from negative to positive. Is that a max? Negative to positive, that's a min. So can I cross this one out? This one went from positive to negative. Okay, this one went from positive to negative. So this one is a possibility. This one. Does this go from negative to positive? So the only ones where the second derivative is less than 0 are when x equals 2. The only one that has this stipulation is when x equals 2. These two are relative mins. So this one and this one, those are relative mins. So the only relative max is possibly 2. So to find absolute max, we have to plug in the endpoints and 2. Now, how do you find the actual value of these functions? Well, it's kind of interesting. To find g of x, do you understand g of x starts at 5? Doesn't it start at 5? But when the function is 2. So don't we start at 2? 2x to some value. And won't we make this then g prime t dt? I chose t just as another variable. Aren't we going to be plugging x in to this function? Won't we be changing this value? If we start at 2 and we're going to some value, this is your derivative graph, the graph right here. We start at 5. At 2, we start at 5. So this adding up the sum of the integral will give you the actual position of it. That position will tell you max or min. So what values do we need to check? Well, we first need to check, the values we need to check are negative 3, this one, and this one. The three values to check are those. So we plug in negative 3. So we're going to find g prime negative 3 equals 5 plus or minus the integral negative 3 2 of g prime t dt. And then we're going to find the rest of these, which would be g prime, 2, which is 5 plus the integral from 2 to 2 of g prime t dt, which isn't that one 5? And then we also need g prime 7, which is 5 plus 2 to 7 of g prime t dt. So we're going to find those two and find out which one's the max. How do we do that? Well, can I find this area under this curve? Isn't this just saying the area under the curve from here to here? Now, isn't my interval backwards? Is my interval backwards? Yes. So what we're going to do is we want the opposite of it. So can I find the area from 2 to negative 3? And I want the opposite of that. So what's the area of this? Isn't this an area of 1/2 plus 1? So isn't this 1 and 1/2? Isn't it an area of 1 and 1/2? What's the area right here? Well, isn't that like a 2 over and 4 down? So 2 times 4 is 8. So isn't this negative 4? So negative 4 and a 1.5, what's that give us? Isn't that going to be, by the way, isn't this a minus? Because isn't it opposite because it's upside down? So it's minus, and what's this answer? Isn't this negative 2.5? So again, this is a negative 2.5 area. We're minusing it because it's backwards. So you actually end up with 7 and 1/2. And for this one, you go from 2 to 7. From 2 to 7, the area underneath this curve, this is down 2 over 1, 2, 3, 4, 4 times 2 is 8, so this is 4. And this is 1/2. This is a negative 4. So that area is negative 3.5. So this is 5 plus negative 3.5, which is 1 1/2. So which of these values is your max? What you would come to know and conclude is that your maximum, your absolute max, is, this is your absolute maximum right here, and it's when x equals negative 3. So basically, g of negative 3 equals 7 1/2.